Hi there. Let's look at another LeetCode problem. Today we are solving. A second. Today we are solving problem 212. So this is word search proof. Okay. Given an m times n board of characters and a list of strings, words, return all words on the board. Each word must be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once in a word. Again, it sounds like the word search one. If I remember correctly, there is a problem that we solved that in a board that involve a word, but instead in here we are solving for multiple words. So I think that is the added complexity there. So let me just jot down some on the questions. So we are given n times n and list string word. Now you want to return word in board. Okay, so now let's look at the examples there. Example 1, we have O, A, N, E, T, A, E, I, H, K, R, I, F, L, E. Now the word that we are looking for are oat, pea, pear, eat, and rain. So oat is not there. No, actually oat is there. So oat is there. Pear is pear there. Nope, there is no pea. Then across the eat. So yes, we do have eat. Rain. So we have, let's see, we have an R, but it just stopped there. Okay, so the answer would be oat and it. Example 2. Have A, B, C, D. Then what we are looking for is A, B, C, B. A, B, C, B. Now there is A, B, and then it just stops there. So the output is empty list. Alright, I think the question is very clear here. I would like to ask you a clarifying question. first one is what are the number of words? So length of words. And then what does I kind of think of a question to clarify earlier on. Um, okay, let's just check the question length of word. Length of word is between 1 to 3 times 10 to the power of 4, so that is quite a lot. Yeah. And then about the length of each word. Yeah, so it's given by 1 to 10. 3. What are the m times n? 1 to 12. Okay. So I think that would be enough for us to know. Okay, so let's. I think we got all the details that we need now. I would like to start exploring. I think it's time to start exploring some possible approaches. So the number of words is quite a lot, but each of them is quite short. And the size of board itself is quite small, so that we know. If we use the same approach that we did in the word search one, I think that would take much longer. Okay, so how about hmm, so if I build a tribe, is it gonna have then there are 144 elements, 144 cells. So if I build for them all, then it is quite large. Yeah, it is quite large. And because the trial will grow exponentially. Because from a cell, we are moving for direction, and then it keeps on going and going. So it's like 4 to the power of like 100. So it's not possible to build a try for all the possible words. But how about we build a try for all the words? Is it gonna help? Okay, let's see. So, I think if we sort the word, then it could ease our process of searching, is it? So if we build a try, then okay, so if we build a try on the word, then that is just like searching for the word I mean the bot. So let's say we have pair there. Oh, is it P? Okay, anyway, so if we are looking for P, but there is also P's with S, then we don't need to do it twice. Once we search that there is pair, then we can move on. We can just continue, so search for the S. Yeah, so I think that would be an optimization that we could do here. Because like as I said before, if we have P and P's, then we are basically doing just one search instead of doing two at a time. Instead of doing two search, and that would basically collapse two words into one word. So given that we have 3 times 10 to the power of 4, and each of it has a length of 10, so if I do a quick check, then that would mean we have n times, 3 times 10 to the power of 5 character that we need to go through. And say we have 12 times 12 but then there would be 144 starting point. So let's just take, say, 200. So if we multiply them all, then that would be, see, so initially we have 3 times 10 to the power 4 times 10, and then if we times 200, then that would be like 6 times 10 to the power of 7. And then each of it, okay, yeah, I think that would be. So let me see here. So time would be 3 times, let me start from the board side. So 12 times 12. So there are 12 times 12 starting point. And then the length of word is 10. So if we put on there 10, I'm gonna assume that there is only one path, so it may be more than this. But anyway, so this will be 3 times 10 to the power of 4. And at the end, we have around 6 times 10 to the power of 7. Okay, I think if we optimize it, as I said, if we are using a trie, then that will optimize it further. Yeah, I guess that could work. Let me see if there's anything else that I missed. Yeah, I think we could. So let's see if we create a type for the words. Then when we search for it in the bot, then we basically only search for the longest. So we need to search for the branches as well in the chart. So we are exploring all the possibilities. Is that the case? Alright, so I think what we can do is that at each shell we need. Okay, so let me write on the step there. So finding one build thrive onwards to optimize the size. So step one, at each shell so for each cell we check the neighbor if it is in the thread. If so, then we go in. Okay, so if there is a thread, then we explore it. And then in the end, so let's just say in the end, if we encounter the end of the word, then we mark it as true. I think so. Let's see. Okay, so step 2, if each word, then we add it to our actual solution set. Okay, I think that kind of make our. I think this makes sense to do, because as we are exploring all the try, and we encounter that there is a solution, then we add it into our solution set. Okay, so now with this step, I would like to test it on the example to make sure we can get the answer for it. For example 1, we have O A N, then E T A E, and then we have I H K R, and then I F L E. Now let's build the try. So we start at nothing, and then out. Then there is pair, and then there is E, and also ring. Okay, so for O, we found that there is an O there. Do we need to explore the E? No, because we don't have E there. So we go to A. After A there is T, so we go to T. We don't need to explore the other A because there is no words that go there, that part. And then we end up at H. So that gives us the out as a solution. Now what is a solution? Then we add it into our set solution. Out. And then P, if we search for P, so now we go to the A, there is no chart that starts at A, and then skip that until there is E there. So E, there is nowhere to go, so it is not the solution. But the second E, we found that there is a solution, so we added it into our solution. And then ring, we have an R there, but there is nowhere to go, so we just stop there. Okay, finally we have out and it. I think this works. Second example, we have A, B, C, D. And then the try is A, B, C, D, but there is nowhere to go. We have A, B, but there is no A, B, C, B. So solution set is just empty. Okay. Now let's work on the implementation. So we are given the function find words, word, and the words. Okay, so for the words, we are gonna build a try. So let's call a try. Now we need to add all the words into the try. So how we gonna do that? We are gonna let's see. So and do it recursively or iteratively. I think I'll just do it recursively. So let me define a function. Find add, and there is word. Anything else that I need? I need the tick. Also, I create a class instead. Okay, I think this should work. So do if if word of 0 in date, then what you're gonna do is let me think for a second. So if length is 0, then we found it. Okay, so how about this? So if word is an empty string, word is 0, then we specify that there is a word that ends here. So how are we gonna do that?
Okay, so how about though we pass in the word and the index? So at what position are we currently in the word? Now that changed the situation. We need to check if I equals the length of word minus 1, then we create in the dictionary to indicate that we have reached the end. So take ending. So let's see. I think we just call it word. So tick of word equals word. Okay. Now we return the tick. Hold on, is tick passed by reference? We check it. Okay, so I don't need to return it. Right, so I think we could do this and then else. If it is not the end, then we check if it is in the word or not, in the dictionary or not. Okay, if word of C of the I, sorry, if the word of I not in tick, I think I should call it try. So try. If the current character is not in the try, then we are gonna add it. So try of word of I equals dictionary. Then we add the next characters all the way to the end. So word of I plus 1 and then try of word of I. Okay. I am actually not sure if this could work. So let me try to implement this and then test it in LeetCode instead. So let's do it step by step. Now here I am going to define add word I and then try. So if I equals length of word minus 1, try of word equals word. Alright, this should be the last one. Yeah, okay. Then that makes more sense. Else, because if we have reached the end, then there is nothing else to add into the try, and that means we have reached the end of the string. Okay, cool. Now if the word I not in try, then we add it and a new empty dictionary. Then we add further. Yep. Now what we're gonna do is we define an empty div as the try to start with. And then for word keywords, we are gonna add the word into the try setting at the initial point. Okay, now let's print it out to see if we get a wrong answer. But okay, so we got OATH and the word is odd. PEA, word is P, and then it. Yep, so our add worked as expected. Now we need to work on the search. So define search. And what are we searching for? I think we need X and Y. And then we check the boundary. So that means we need to do if so let's see if X is less than or equals to no. So if X is less than 0 or Y is less than 0 or if it exceeds the boundary and or n y, then we return. Else, then we can search further. Okay, so I think we need to pass on the try also. So try. So if the board of x and y, board of x, y, not in try, then we also return. Okay. Actually, do I need to check the boundary? Yeah, I think so. Okay. So we enter all the cells and then we see if it is in the current try. If it is not, then we return. Otherwise, we can explore further. Okay, before we return here, we need to check if there is a word there. So if word in try, then we found the solution. So solution.add, add it into our set of solutions. Otherwise, at the end, we can explore further. For dx, dy in direction, I'm gonna switch through the x plus dx, y plus dy, and then this would be the try of both xy. Yep. So like before, I'm gonna set the m and n. So m is length of both, n is length of both of zero, and then we initialize solution to an empty set. Okay, I think that should work. Now let me go through the code again to make sure I don't miss anything. We first of all we search through all the cells, and then we check whether we are out of bound or not. If it is not, then we see if we currently have found a word or not. If we have found it, then we add it into our solution set. And now it is time. Hold on. Are we supposed to do it here? I think this check is not to be here, but we can do it in the below part. So yeah, so I think what we need to do instead is check whether the word so hold on a second. So what we need to check is if word in the try of both xy, then we add solution dot add try both, then would. Okay, and then we can explore further. So let me check, test our code with the example input. So when we reach O, the first cell, index, the position is valid, the X and Y is valid, and the O, both X, Y is in the try, but the word is not in O, so O is not a word. So we continue. Let's say if we move down, then we see that E is not after O. But when we move right, there is an A, and if when we reach an A there, we continue until there is an H. So after we reach H, we see that H is in the try, and also there is a word in H. It means that we have found a solution. So we could add it into our solution, and then we explore further. So after H, we move left, we see an I, but there is no I there, then there is no K, there is no F, so we return everything, and we have found a solution. And then same for P, pair, P, there is no P there, but if there is a solution, then ring, there is also a solution. Okay, one thing that I forgot to do here is that before it's further, we need to set the current character into empty string, so that we don't explore this part further. Okay, so what you're gonna do is that you're gonna store it into dummy and then set it to empty string, and then we could proceed further. Okay, so I'm gonna change it directly on the LeetCode. So what we're gonna do is n equals length of both length of 0. Okay, now solution is a set, and we define the search at x, y, and right. Okay, so if x is less than 0, or y is less than 0, or x, we exceed the boundary, and y, then we return limit for x, y not in try, and we also return then if word in try actually we don't need the current try anymore. 1 second. So now try. As we count the try of both x, y. Yeah. So in try, then solution dot add try of both. Okay. Now we are gonna search through all direction. Putting sty in the direction, search for x plus dx, y plus dy, and then the try. Okay. So we haven't defined the direction yet. Direction is just that the previous question we have seen -1 0, and then 0 -1, and then it's 1 0, then 0 1. Now for x, y in range and y in range and now we search for x, y and try. I think this is called among local and solution and direction. Okay. So it and so we haven't returned. Solution. Okay, so it has to be a list. So we got that. I just learned that Python has enforced the return types here. Okay, so we got the correct answer. Alright, let's try to submit it. It's taking some time. I'm worried that I might get a key out E here. Okay, so we got the wrong answer. Okay, so forget to implement the dummy. Okay, dummy. And the board. Wait, I think I'm going to call local board x, y. Then this is empty string. Here we set it back to dummy. Okay, let's try to run that. Got it alright. Now let's try to run. Yep, we got this correct. Okay, so there are a lot of submissions that are much more efficient. And it is by 10 times. Okay, that is surprising. Okay, let's have a look at those submissions. That turns out to be very efficient. But why is it so long? Hmm. Okay, let's look at maybe this one. Yep, so DFS try IJ, then it builds to try what's in words, not equals try. C in W if C not in index. Okay. Mhm. I think that is what we are doing as well. So what is this doing? Not the pop, the time. Hold on. Okay, so I think it's doing much more optimization, meaning that if you found the solution, then you don't need to search for it again. Is that what it is? Success from empty branch. I'm a bit confused what it means by empty branch. Now, um, after this, we just delete it from our solution, I mean from our file. So file dot remove solution and then what? Okay. Then after I search, just have a chat. Hmm. Okay, I think I can do it here. So if dot x1 if not, then we can remove it. Remove. Okay, to send value. Okay, let's test this. Um, what is the content name that I use? Keyword I is it talking about here? The word dick has no name of set return remove non-set. The object has no attribute remove. That's weird. Okay, that's set to the dictionary. So it's pop. So let's try this again with the pop. Keyword again. Hmm. I'm a bit confused here. Keyword. Ah, okay, I think I know. I see. Okay. So there is possibility that it is not in the type. If this is in type and not right, that then we pop it. less index out of range. Okay, let's just print the try here. Oh, I see. So it's out of range. Okay. I think it's better if I move this down there. So I'm gonna copy this, comment this up, and then I'm gonna check here. So new x and new y equals x plus dx y plus dy. So then this will become the new okay. Now if this is the case, then we can move this. New and then new. New, 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 and new. So let's try this. Still got an error. List out of range. If okay. If new x and new y and then we search. Yep. Let's try this. I hope it is a bit more optimized. Yes, this is much more efficient than we previously had. Okay, well, I guess we will stop here. I'm pretty good about this now. So actually, let me quickly have another look to see if there is further optimization that we can do. We remove the word, add the solution. Then set the done. We set the done. Okay, then we can listen that. Okay, let's get Python. So the top. Can we pop an element that doesn't exist? So the pop does not exist, then we get a key error. So we need to check and put this inside. Actually, we don't need to check it here. So what we need to do is make sure that it is in the pop. It's in the pop. Then we enter it. What is happening here? At the try, okay, so let's print the try here. Try. See what we got. Oh, okay. Because when we first search for it, okay, see here. If we need to do another check here. So before we enter, we check it first. And then let's try that again. Then this is much more optimized again. And yes. Actually, this one, there are some more solutions that are still much more optimized. So let's quickly go through that. And try to find something that are clean. Okay, let's look at this one. Find words. Setup work form. Setup and work. IT the append IT. Right, so the first is set word. Then one of word divided by 2. And one of this is use different like tree. It's kind of simple is building because such a one does not have such a high requirements to stay. If you place it, um, um, so basically it is written out here. And there is such model that is more popular. If you replace it, then it's not other everything upper level, and the left is also ends the original method. I think that is much more efficient. How about we cancel that? So I think it is simple to do. I'm assuming that I can modify the input. biết là từ nó là gì đấy. Nhiều cái một cái gì. Cái đời mình scan for this and looking through other maybe person transform or person the another. Okay, is pretty amazing. So guess I can stop here, okay? We have optimized it to our test. Okay, okay. Because stop here. So because this is my intention. Because I just noticed something, this is not using a file. It does it strong on the see what principle looks like. Yeah, because we sit in the can do that maybe. Okay, stop here. So it is acting now. But I think this has something to do with the time and the day. So